Hey, what's up everyone? This is Tyson. I'm here to teach you today how to program the Titan-84L. This is the first lathe tutorial that we're doing. First thing you're going to need is your setup sheet, your print, and your model. So go ahead and download those if you don't already have them. You can get those right here on the side of the video. And the very first thing we're going to do before we start programming the part is we're going to make a small edit to the model. So make sure you're in your model workspace. And you're going to go to your timeline here, and you're going to find where your thread is. You're going to right click on your thread, and you're going to hit Edit Feature. And the threads do look good in 3D, I really like them, but they're going to get in the way when we try to turn across them. It's going to think that each of those threads are something that the lathe tool needs to turn on. So on this checkbox here that says Modeled, let's turn that off. You can see the threads turned solid just now. You can still see that there's a thread that's supposed to be there, but now it's just going to go straight across when the tool goes. So we'll hit OK, and we're ready to start programming. So the next thing, let's go to our CAM workspace this time. We'll go to our Setup tab here, and we'll hit New Setup. It's going to ask what kind of operation type we're doing. We're going to be doing turning. And for the work coordinate system, we need to set where the front of our part's going to be. So we need to set a Z0. I'm going to select this corner here, which I'm going to treat as the front of my part. And that does look good, except that our origin here is set to the front of our material. I don't want that. So for the origin, I'm going to go to model front rather than stock front. And there we go. We're set now on the front of our part. That's going to be Z0, and everything is going to be programmed off of that point. I do that to almost all of my programs. I want the front of my part to be where the Z0 is. There's no more confusion when you're looking in your program. You know if you need to go 100 thou deep, you're going 100 thou deep from the front of the part. So we got that set. We don't need to mess with our x-axis or any of this other stuff here. So let's go to our stock tab. Now we need to set our stock diameter, which I'm running a 1-inch bar. So I'm going to use 1 inch, but make sure that matches up with whatever you're cutting. So for model position here, let's make this offset from the front. So what that does is it moves your model closer to the front of your stock. So it looks more like you were running bar stock. We'll go to this offset tab here. And I'm going to put 20 thousandths because I want to do a 20 thousandths face cut. Everything else looks good there, so we'll hit OK. And we're ready to start doing our tool paths now. We'll do our first one. We're going to go to Turning Face. We'll need to select one of our tools. Let's go to our tool library. I'm going to select tool number 1. This is our 55-degree OD tool. We're going to be using constant surface speed and feed per revolution. On almost all of our lathe tool paths, we will be using those. So for surface speed, I'm going to go 800 SFM. I'm going to limit our max spindle speed to 3000, and that's when it goes to its lowest point on your diameter. That's the fastest the spindle will spin. Feed per revolution, we're going to go 8 thousandths. A little bit slow, but we're learning. We're going to go to our radii tab here, and for clearance, we're going to change this from 400 thousandths to 200 thousandths. Bring it a little bit closer, not too close. Again, once you get better, you can bring it a little bit closer. Inner radius, just make sure it's set to 0. Stock ID, just center of the part right there. You don't have to mess with any of these other ones, so clearance is fine. Stock OD is fine on that one. For passes, we're going to use stock to leave, turn that on, and I'm going to leave 4 thousandths. And your last tab is your linking tab. This is going to decide your lead ins and lead outs for the tool, so how your tool approaches and at what angle it's approaching. So for the lead in, I'm just going to use a 90-degree lead in. That's just going to go straight down. For the lead out, I'm going to make sure that this same as lead in button here is unchecked. You don't want that on. And the lead out angle is going to be a 45 degree. I usually leave those lead in lengths. Usually 80 thousandths is fine. I usually do 40 thousandths. We'll leave those at 80 thousandths. So everything there looks good. Hit OK. And we got our first tool path done. One face pass going about 4 thousandths away from the part. We'll go ahead and bring it closer later once we do our finished passes. We're not done using that tool though. So I'm going to go to turning, and this time I'm going to do a turn profile. We're going to cut across the OD of the part. It's already got our tool selected, so that should be tool number 1 there. And you're going to make sure that we're using outside profiling. Our direction is front to back, so from the front of the part to the end of the part. And your grooving tab, we're going to allow axial and radial grooving. So what that is, it's going to let us turn into the part a little bit, or as they call it, we're going to do undercuts. Your speeds and feeds, it's going to match up with whatever our last tool was. So 800 SFM, max spindle speed of 3000, and a feed per revolution of 8 thousandths. Go to our geometry tab here, and we need to tell it where we want to cut here. So I'm going to do, for the front, I'm going to select stock front. So it's going to start where it thought the material was. That's fine. I just want it to start at the front of the part there. So stock front, that'll give it a little bit of space from the front where we faced. For the back, I'm going to go here and hit selection. So for that selection, I'm going to hit this point right here. And for the offset, we're going to make it 0. What that's going to do is it's going to turn up to this chamfer here, and it's going to stop there. I don't want to turn the rest of this part just yet because I want to do the front of the part. I'm going to get the threads done and everything. And then once the front's done, we're going to do the back. The reason is it's going to get pretty thin back here. So we'll do all the work up front first, and then we'll take care of the back work. So let's go to our next tab, the radii tab. Your clearance, you can leave that at stock OD, 200 thousandths away. You can leave the retract and outer radiuses alone. We're going to go to our inner radius here. We're going to use selection. What we're going to do, we need to make a selection on where we want that inner radius to be. I want it on the front of the part at the end of this chamfer, right there. And for the offset on that, we're going to go -10. So it's going to start just a little bit below that chamfer there. And it's going to end right at the top of that chamfer. That looks good. We'll hit OK. We're on our passes tab here. The most important things on this tab is to make sure the finishing passes tab is turned off. I don't want to do a finishing pass just yet. We're going to turn on the roughing passes tab, and we're going to do 80 thousandths depths of cut. For the stock to leave, we're going to leave those at 4 thousandths. Go to our next tab, the linking tab, and for the lead in, we're going to do a lead in of 0 degrees this time. It's going to go straight across. For the lead out, we're going to use a 45-degree lead out. You can go ahead and leave the lanes at 80 thousandths. That's fine. And everything there looks good, so we'll hit OK. Now we got our first pass done. You can see it goes into that groove a little bit, but it can't quite go down all the way because of the angle of the tool. So we'll take care of that in a second. So the next thing we're going to do is we're going to go to turning, and we're going to go to turn single groove. We're going to select our tool, tool library. We'll go to tool number 6. This is our 63 wide groover. You're going to make sure that we're on outside grooving. For our speeds, we're going to use a surface speed of 400 SFM, maximum spindle speed of 3000, and for your feet per revolution, let's go with 3 thousandths. Next tab, geometry, we need to select where we want to cut our groove. We do have one problem with Fusion single grooving. If you have a fillet radius in your part, you can't actually select the corner or the fillet radius. You can select the top of the fillet radius, or you can select the bottom of the fillet radius, but you can't actually select the fillet radius. So you need to select the furthest point on the tool that you're going to be cutting. So in our case, our tool, we want to cut along this wall right here, and we want to go all the way to the bottom of the groove. So you have two options. You can either go to the model and you can delete that fillet radius right there, and then on this page here, you'll be able to select that corner. Or you can go ahead and select this corner here, and we're going to tell the tool to offset it down as big as this radius is. So when I get to that page, I'm going to offset this minus 16 thousandths. Before we do that though, regardless of which way you approach this, you'll need to set your groove side alignment. That's going to be basically where you touch off your tool. So rather than the middle of the tool, we want this set to the front of the tool. And you can see our preview suddenly appeared right there. That's good there. Clearances, we'll leave this at 200 thousandths. And if you don't already have it, you can set that as your default. Make that our default. All the rest of this is fine. You can leave those at 0. Stock to leave, since I have that fillet radius there. I'll check that. And we're going to put a negative number and I'm going to just tell it what that fillet radius is. So I'm going to go 16 thousandths. But if you deleted that fillet radius and you just have a sharp corner there, you can just select that corner and you don't have to leave any stock. Just set that at 0. All right, so let's hit OK. And as you can see, we've got our groove there. You can see our fillets on our model are bigger than the fillet of our tool, but regardless, it's still in spec there. So we got our thread relief done. Let's get the thread in there. Go to turning thread, select our tool, go to our tool library. We're going to select tool number 3, which is our OD threader. For your turning mode, we're doing outside threading. For your speeds and feeds, we're going to turn off constant surface speed on this tool. And I'm just going to turn this at 1000 RPM. For the feed per revolution, this one's a little bit tricky. So the feed of a threader, it goes at a certain speed in order to give it that spiral that a thread has. So the speed of your tool is basically going to be what the pitch of your thread is on a lathe. Basically, the inch per revolution is going to match up with the threads per inch of what type of thread you're cutting. So you need to type in the pitch for your feed per revolution. So we'll get our calculator here. So in order to figure out the pitch of your part, we're going to take 1 inch and you're going to divide it by how many threads per inch on your part. So we'll look at our part. We've got a 3/8 by 16 thread. So just go 1 inch divided by 16. That'll give us 62.5. You're going to be using that number, so write it down or memorize it or just reference back to this page here. But we'll be using that in a second. So 62.5, 62.5. All right. Go to our geometry. We'll need to select where our threads are cutting. So select your thread. This is a little bit hard to see because we have thread fade on, but you can see it's trying to back off on that thread there. We're going to go to our passes tab real quick, and I'm going to turn that off so it's a little bit easier. So fade thread end, make sure that's turned off. Go back to our geometry here. So this here, you want this threader to go all the way to the front of this part here. You don't want your thread to just stop there, otherwise it's not going to turn far enough. So on our backside offset here, we're going to tell it to go further. So to figure out how far, you're going to take the distance of this chamfer right here, along with the distance of how wide your thread relief is. So we'll go 60 thousandths plus 35 thousandths. So now our thread will turn far enough and go into the thread relief. Go to our radii, 200 thousandths for the clearance, passes. Now you're going to make sure that we're doing a right-hand thread. For our thread depth, we'll also have to bust out our calculator here, and we're going to do a little bit of math here. We need to tell it the distance from the outside of the thread or your major diameter to the inside of your thread or your minor diameter. So what we need to do is you're going to take the major diameter, which on your part is the OD of the thread, which is 0.367. You're going to subtract it from the minor of your thread, which is 0.295. And then you're going to divide it by 2. That gives you 36 thousandths. We'll go here for our thread depth. 36 thousandths. For your number of step downs, this is how many passes we're going to do on your thread tool. We're going to do 13 passes. That seems like a lot, but your threaders aren't very sturdy tools, and it's going to be a very fast pass. For your thread pitch, we're going to take that number that we put in our feed rate earlier when we calculated the thread pitch. So when we took 1 inch divided by 16, that's going to be 62.5. For the in-feed mode here, I'm going to do reduce in-feed, and for the angle, 29 degrees. And we don't need to check anything else here, so we'll hit OK. And we got our thread pass done. So we're almost done with the front of our part here. We're going to add in our finish passes. The way I like to do this is we're going to select our 2 earlier rough passes, so our face pass and our OD pass. We're going to right click and we're going to hit duplicate. Then I'm going to take my newly duplicated passes here. We'll select those and we're going to drag them to the bottom of our list here. Now we're going to edit those passes and we're going to turn them into finish passes. So we'll start with the face tool, select which tool we're going to use on there, and I'm going to select our finisher, tool number 2. For your speeds and feeds, we're going to change this to 600 SFM, still use our max spindle speed of 3000. We can leave our feed rate at 3000ths. For our geometry and our clearances, those should be all the same as the roughing tool. We're fine there. But on the passes tab, we're going to uncheck stock to leave. Now it's not leaving any stock and it's going to do a finish pass. Linking, we can leave that all the same as our roughing pass. So we'll hit OK. Now we'll go to our duplicated profiling tool here. We'll edit that. We'll do the same thing. We're going to edit, select our tool, that finisher that we just used, tool number 2. Turning mode and everything should be the same as that previous tool. So we're good there. Feed and speed, 600 SFM. 3000 max surface footage, feed rate of 3000ths. We still got our geometry selections from when we roughed it out, so we're good there. Our clearances are all still the same. On our passes tab, we're going to uncheck roughing pass, and we're going to uncheck stock to leave. So we have one finish pass. Let's hit OK, and we got our finish pass done. Look how easy that was. It's one of my favorite things about Fusion is being able to easily edit a roughing pass and turn it into a finish pass within a blink of an eye. Alright, so the front of our part's all taken care of. Let's take care of the back end now. So before we get started with the rest of our part, if you look at our tool list here, we have some tools that are labeled almost the exact same thing. So I'm going to go and I'm going to give these labels. So rough face, rough OD, grooves fine, threads fine, finish face, finish OD. That way I don't get these tools mixed up. So since I love duplicating things, I'm going to right click on this rough OD and we're going to duplicate it. Let's take this duplicated pass and drag it to the bottom. It's at the end of our list now. I'm going to label this one rough OD back. So I know that I'm roughing the back side now. Now let's edit this pass. We're using our roughing tool again. Turning mode's still outside profiling and we still want radial and axial grooving. Our surface speed, I'm going to turn these down a little bit. So 600, and I'm going to drop the max spindle speed to 800 RPM. We can speed these up later, but I am worried from how little is holding on the end there. So after my first part, I'm going to bump those back up and see how far I can go. But for now, we'll do 600 SFM and a max spindle speed of 800. Our feed rates will leave the same. 8000 should be fine. Now on our geometry here, we do have to make a couple of changes. For the front, we're going to go to selection. I'm going to select that point that we ended at the end of our rougher. So the end of our chamfer right here, we'll select that. And that's going to be my front of the part. Don't need an offset there, so we'll go to our back here. So we're basically picking up where we left off on our roughing pass. For the back, instead of selection, we're going to do model back. And on our offset, I'm going to go -15. So just a little bit further past because I want to use this tool to do this radius right here. So that's good. We'll go to our radii tab here. And under inner radius, I'm going to uncheck this. We're still going to use selection, but I'm going to select a different point on the back side of the part, which is going to be the end of this back radius right here. So let's click that, and now we're good. We can still leave that offset of 10,000, so that's not going to hurt nothing. So let's go to our passes. For your roughing passes, we'll turn those down just a little bit. 60,000ths roughing pass. We can leave 4,000ths on the stock to leave tab there and make sure that finishing passes isn't checked, and it shouldn't be since we duplicated the roughing pass. All our other stuff is good here. It's all the same as that first tool we did, so we'll hit OK. And we got our roughing passes. Now if you remember, for our lead-in on our roughing pass, we did a straight 0-degree lead-in. But that doesn't make any sense when you're doing your undercut because now you're dipping into the part here. Fusion will figure out what angle to approach these undercuts once it starts digging into the part here. So you're fine leaving that lead-in where it's at. It'll figure out the right angle to approach these cuts. So we got that done. Now let's take that pass and we'll duplicate. We'll take the second roughing pass, and now instead of roughing OD back, I'm going to name it Finish OD Back. We'll edit this. And just like you did on the finishing tool, we'll select our finishers. Everything should be the same as the roughing. Speed and feed here. We're going to go 400 SFM. Limit our spindle speed to 600 RPM. And we'll use a feed rate of 3,000. Geometry, that's all the same as the roughing pass. Same with our radii tab. So we'll go to our passes. We're going to uncheck roughing. And we're going to uncheck stock to leave. Now it's just one finish pass. We'll hit OK, and we got our finish pass. Look how easy that was. All you have to do to change a roughing pass to a finish pass is just select what speed you're doing and uncheck the roughing tabs. So we got all our passes done. OD is all done and our threads are done. So let's get this part parted off. I'm going to go to turning and go to turning part. Now, it did select a groover, which is our 63 wide groover we used earlier, but that's not the one I want to use. So I'm going to go to our tool library, and I'm going to select tool number 4. This is our actual OD part off. It's 118 thousandths wide. And for surface speed, I'm going to go 200 SFM. I'm going to do a maximum spindle speed of 800. We can leave our feet per revolution at 3 thousandths 5 tenths. That's fine. It's already selected the back of the model for where our cut's going to be. And just make sure our clearance is set to 200, a little bit away from the OD of the stock. All of our tabs here, we don't need to check anything. Just leave these all unchecked. We should be fine. We'll hit OK. And now we got our part parted off. It's all complete. It was that easy. Did the whole thing in one operation. As soon as this is done, all you have to do is just clean up the little leftover bit from where it parted off and you have a done part. Just to make sure, we'll click on our setup here and I'm going to go to simulate. We'll turn on stock so you can see the stock that's being cut. And let's play this. Let's see what happens. Speed this up a little. So we got our OD roughing pass. We got our thread relief there. You have our threading pass. It never quite looks right when it's simulating. You can kind of get an idea, but what you want to watch out for is just making sure the front of the tool isn't going to rub up against some stock or, the side of the thread relief. It seems like it's a while, but it's actually going to go really fast in the machine. We got our finish face and your finish OD part 1. Now we're going to rough out the back end here. Going into the undercut there. Now it's going to do a finish pass. Look at that. Finally, it's going to do the part off. And there you go, one up and done. All right, our part's all programmed. That wasn't too hard, right? So all that's left to do now is we basically just need to post our program and make sure our tool numbers match up with our tools in our machine. And we have plenty more lathe tutorials to do, so I will see you then.